Hi everyone. So today we are going to start the discussion on ray optics. Okay, you know what is ray optics, right? And you must have studied in class 9 or class 10, right? Yeah. So let's talk about ray optics. And before going to talk about ray optics, I would like to give you some idea. That is, I would like to give you what is the history. Or what is the difference between ray optics and ray optics? What are the things behind that? And let me take you to some history. Okay, so we will consider that first. And you know that you must have heard Newton's corpuscular theory. Newton's corpuscular theory. So it says that, look at this. It says that Newton believed or Newton considered that light as a particle. Light, we are going to talk about ray, light, right? So that is why this chapter name is ray optics. Okay, ray optics and optical instruments is there, but optical instruments we will discuss later. And now ray optics. So Newton actually considered light as a ray. So what is Newton? Newton. So I would to get you an idea. So I would like to Newton ray. Ray means it's a particle. Okay, it's a particle. So we consider it as a particle. So it says for example, by using the Newton's ray or corpuscular theory, we could find, or we could say that light's properties, just as reflection, refraction, total internal reflection, etc. Okay, so we found out, or Newton could prove reflection, refraction. So I would write here reflection. Don't worry, you must have heard all these words, and we will discuss them again and again. Don't worry about that. Reflection, refraction, and total internal reflection. Okay, so if you don't know this, don't worry, we will discuss that. So Newton could explain all these things. Then who came? Then Christian Huygens came. Okay. And he said, no, it's not, light is not light is not a ray or a particle, light is a wave. So that is what is wave optics. We will discuss all the properties over there. And you have to study wave optics after this, right? Okay. Oh, ma'am will take you, ma'am will discuss ray optics, wave optics. And what is Huygens said? Huygens said it's a wave. And after this, Young came, and many scientists, they worked on it, and they initially, and when Huygens said light is a wave, actually nobody had accepted at that time. So why? Because Newton was very famous. And you know that Newton is a god of physics, right? Newton, everywhere Newton is there, right? For example, in Newton's law of cooling, in thermodynamics, first year we have seen Newton. In Newton's laws of motion, in laws of motion also Newton is there. And Newton's rings and Newton's corpuscular theory, optics, Newton is there. So Newton was like a god of physics. So Newton said it is a particle. And then at that time, so all science community, they accepted that. Okay, then suddenly Christian Huygens came and he said, no, it's not a particle, it's a wave. Okay, so nobody had accepted him at that time. But the thing is, then, and also by using its wave theory, many other scientists like Young, they could prove, prove interference, diffraction, and polarization, etc. Okay, also along with this, they could also prove that light shows reflection, refraction, and as well as TIR. Okay, so which means by using Huygens wave theory, like we can show, light can we can prove that light shows all these properties, and by using Newton's ray or particle nature of light, that theory we can prove all this. So which one would you prefer? You would prefer Huygens wave theory Because by using Huygens wave theory, like we can prove all those things. Okay, or we can see that light shows all those properties. Okay, so then and you will have a doubt, what is the meaning light is a wave, light is a particle, what sir is saying. Don't worry, so we will discuss all of these things. This is just a history and that. Okay, and later, and one more thing, this is optics is over here, but one thing, that is in 1905, who came? Einstein. Okay, the other genius, Einstein came, and Einstein proved one thing. What is that? Or Einstein worked on something that is photoelectric effect. You will study in modern physics that in dual nature of matter radiation, photoelectric effect. Then what is photoelectric effect? That is, a light is coming or electromagnetic wave is coming and it will eject one electron from the metal surface. So, or from the target surface. So, according to Einstein, so it shows like photoelectric effect. Light can show or light can have photoelectric effect, or that means only look at this. This is a momentum is actually ejecting one electron. Momentum that we have studied in 11. Momentum is ejecting one electron. So only a particle can do this, not a wave. So then again a confusion. So what is meaning? So actually initially Newton said light is a particle, then Huygens said it is a wave, then after a long time, 1905, Einstein said it is a particle again. It shows particle nature. Okay, so we cannot prove that by using the wave theory. This one, photoelectric effect. Photoelectric effect. Okay, so what is exactly happening here? So that is why our chapter, modern physics chapter name is dual nature of matter radiation. Dual nature of matter radiation. So it shows both wave nature as well as particle nature. So that is the introduction I would like to give you. And one more thing, you just listen. We are considering light as a particle here. So that is what we are going to discuss here. Okay, but you know that light shows reflection, quadrilateral reflection, and scattering, etc. Scattering is also there. Okay, so we have to discuss one by one. Okay, so it's more of a mathematical thing, and concept is there, and as well as you have to apply the maths along with that. Then only you will be able to solve. You will be able to get everything. Okay, so thank you everyone. So we will see in the next video.